All right, so welcome to the review for, sorry, for your exam two. So first thing we're going to look at is just graphing your tangent, cotangent, cosecant, and secant functions. So what's going to help us here is just knowing sort of your basic shape. And then look for things like what kind of like would have been your amplitude. We'll go back over what that was again. A period would definitely be something that would be help. Looks for any kind of shifts. So we might have a phase shift, or you might have like a midline shift. If that was that vertical shift where it shifts up or down. Okay, so just kind of a basic shape here. So I'm going to make some axes. So we're looking at cotangent. Okay, so I'll put pi here. That would be my period. This will be pi over 2. Pi over 4. We're just going to do one period here, and 3 pi over 4. So what we should see here is that when you have cotangent, that is decreasing. So it's going to decrease. It's going to, at this point, hit 1, then go through the x-axis. Then it's going to go through to -1, and then it's going to follow the asymptote. So I'm trying to get a very basic idea of what it looks like. So we should see an asymptote here. And then we know it's going to keep repeating that same shape. So things that we're looking for here, like I said, this is if we had cotangent of x. So automatically we see that this is not going to work because we should be decreasing. Also, pay attention to this. We have this 1/4 out front, so we don't have a reflection, so we know this should still be a decreasing function. Now, what this 1/4 will tell me is this controls these points right here. Make it a different color. And this point right here. So it controls this vertical stretch. So when it's 1/4, what that means is that here it's 1, right? So now it's 1/4. That means this point would have to be at 1/4. So if we go back and we look, so this point is the point it is halfway between your asymptote and your x-intercept. So we look halfway between my asymptote and my x-intercept. We're right here. So let me make that one bigger. So we're looking at right here. And if we go, we look at that, that appears to be about 1/4. So that's one of the things that we could check for. Also, if you looked at this one, another thing you may have noticed that this one right here's my little curve over the line. Here's my little curve. This one actually has a vertical shift. Now, to have a vertical shift means that I would have to have added something, which is a D, on the outside of the cosine, a cotangent, which we didn't. So we know that takes this one out of the picture as well. Another thing that we could look for to help us out maybe is look at period. So if you remember before, it's this number on your x. We call that the B that controls period. So period for cotangent and tangent is pi. So for this function here, my period is going to be pi divided by b, not 2 pi. So that would be pi divided by 5. And what we see is this does have a period of pi divided by 5. Unfortunately, so does this one. So sometimes that's not always going to help you to sort of determine which is the one we want to pick. So what I'm doing here is I'm just looking for some basic things because you could graph this in your calculator, but unless you know what points you're looking for, it's going to be really hard to pick the right graph. So what we notice here is we know that we got a cotangent, so it should be this decreasing curve. We also know that it's going to be between 0 and pi would be 1 period of it. We know that if the A out here in front, if it's positive, it should stay decreasing. So it's not going to cause a flip. And it's going to control these points here. So the points that you normally go that are at -1 and 1, it's going to change where those points are going to be. So here they're going to be at 1/4 and 1/4. And we know that there is no shift, vertical shift, so we know this one's out of the question. So it leaves me with B. So here we have a tangent. So if we just looked at what tangent of x is supposed to look like, that is the one that's always decreasing, and it's going to have an x-intercept at 0. So it has a period between -pi/2 and pi/2. So halfway, because we know these are supposed to be asymptotes. So halfway between where we know we have an x-intercept and an asymptote is where it's going to hit 1. So remember, this one is increasing. So where it's going to start is halfway between this asymptote and the x-intercept. That is your point. And then this is your other point between 0 or your x-intercept and then the other asymptote. So that kind of flattened it a little bit when I was making this. So I know it's going to look kind of like that. So the things that we need to watch for are going to come from what we see in here. So what we know is that we have A is going to be a -4. So because of the negative, we are going to have a reflection. Now what's going to happen is this is going to cause a reflection over the x axis. And we know that these points here are not going to be at 1, 1. They're going to be at -4 and 4 now. We also know that the period, so the B of this is going to be 1/4. So we know the period is going to be pi over 1/4, which is going to simplify into 4 pi. Okay, so using what we know, get a general idea of what we should be seeing. So for one thing, we have to change this line because of that -4, we're going to get that reflection, right? So we are expecting something that is going to go like this now. So now it's changed it from something that was increasing to something that is decreasing. So we see A can't work for us. Oh, sorry, not A. A is fine. B can't work for us. And where's the other one? D doesn't work for us. The other thing we know is now that this period is supposed to be 4 pi. So this is -4/2, 4/2. What you will see here, if you look at the periods of what's left, it's going to be even on both sides still, because this one's going to go from -2 to, or sorry, -2 pi to 2 pi. So that is a period of 4 pi. But this one here, also C, also has a period of -2 pi, or sorry, it goes from -2 pi to 2 pi. So it also has a period of 4. So they have the same period. So that's not going to be helpful. So what we need to look at is these points. So this point was normally at 1, but because that 4, it's now at 4, and this point is at 4. So we just look halfway between the asymptote and the x-intercept is about here. That puts me about here. So this is 9. So it looks like going by thirds. So this is 3 and this is 6. So this puts me right about at 4. Here, this should be 3 and this should be 6. So if you look for halfway between the x-intercept and the asymptote, that's about here. That puts us way up here. So it's telling me that I'm going to be at 9. When we said it's supposed to be at 4, so we know that takes this out of the equation. So it's going to be C. All right, so here we're looking at a phase shift. And once again, we know that what we should be seeing, sorry, my pen wasn't working, is that tangent itself should be looking like this. So it's stuck between negative pi over 2 and pi over 2. So because we add this pi over 3, that means everything moves this way by pi over 3. So we're not centered here at 0, 0 anymore. We're going to be centered here at pi over 3. So things to look for, we already know it's going to be increasing because that hasn't changed. So this is out and this is out. So we're just looking for the one that's centered in the right place. So this one looks like the center. So I'm not sure if that's a shift there or not, but we see that this x-intercept is definitely not at pi over 3. It's at pi over 6, if you can't read that. This one, there's pi over 6. So that looks like that might be pi over 3. On this, you might have to do a little bit of eyeballing. Another thing we can do is we know that this is where my asymptote is. So if I just take pi over 2 and I add pi over 3 to it, that is going to be, let me see, 3 pi over 6 plus 2 pi over 6, which is going to be 5 pi over 6. That also tells me that this asymptote here should be 5 pi over 6, which is what we see here. We have the same thing here too, but like I said, the difference is also that x-intercept. And once again, I think this one actually is shifted up 1. It's a little hard to tell, but I think there's a shift there. So that would be our answer again. So here we got a cotangent. So just our basic cotangent of one more time. So if we're actually looking at one period of cotangent, I just need to move a little bit of space here. Oh, we're on this side. So we should be seeing something that does this as its general behavior. It's going to have an asymptote here at pi, and then this one at 0. So its x-intercept is going to be pi over 2. So this one, we have that part that is going to change my amplitude. So this halfway point, where it's normally at 1, should be at 4 now. So that's one of the things we can look at. We got 2 things we can look for and start eliminating answers. So for one thing, it's not flipped or anything because it's still like this, and that's a positive 4. That's out of the question. And this one's out of the question. So we're left with B and C. We'll just see if this turns out to be C again. Okay, so if we look for those halfway points, so about here, well, that's a little hard to see. That does not quite look like 4. That looks like 1/4. So if we go over here, that's about a halfway point. That looks like it's about 4. So this looks like the one again. We could have tried the phase shift, but as you see, these ones are shifted in the same spot. So the only thing we can depend upon is that 4. So really quickly, you can pretty much eliminate 2 of your solutions quickly just by knowing the basic shape and knowing if it's reflector or not. And then the rest is just trying to identify a few points. So here we got y equals 6 cosecant x. So you don't remember the shape here. Just kind of give you a little help here. So remember, cosecant is a reciprocal of sine. So this is what sine looks like. That means your cosecant will look like, so it should come down and touch right here, will look like this. So we can get rid of the sign there because they were just really interested in that cosecant. So what you should see here, oops, got a little crooked there. This would be 2 pi. This would be pi. It should be an asymptote. So let's remember, just a quick sketch. This would be pi over 2, and this would be 3 pi over 2. So what we have here, the only thing that's being affected is right here. So remember, because we just used a sine function for this. Let me put that sign there again. So we went up, down like that. So sine maxes out here at 1, and then its minimum here is at -1. Which means that when we're looking at this point here, this point is at 1, and this point is at -1. So first we just need something that has this shape to it, which takes out this one because we see here. Let me make that one a little bigger. For one thing, the copy, that is a cosine that we're using, not the reciprocal we're using is that cosine here. So what we got here is actually a graph for secant. So that one's out. This one's okay because, like I said, it's that sine, and we see that we got a cosecant, so we can keep this one. And I think C is the other one we can keep. Yeah, because C is also a cosecant. But D is also a secant again. Because like I said, it's just an upside down cosine curve. That means that my choice is between these two. So where this should be because of that 6 is because everything is, remember, stretching vertically. This should be 6, and this should be -6, which is what we see here. We go up, and we got that 6, and then here's about a -6. 1, 2, 3, 4, 5, 6. Also, because this is a positive, this should have been opening up first, then opening down. This one opens down first, opens down because this one had a -6 in front. That's going to make it our answer. Over here we have a secant. So secant is a reciprocal of cosine. And what we know is that cosine is going to start here at 1, down, up, down. So this is going to be pi over 2. This is my -1. Sorry, that shouldn't be so. Let me fix that shape just a little bit. Sorry, it's the pad I'm using makes this a little hard sometimes. So that's kind of a basic cosine. This will be pi, this will be pi over 2, this will be 3 pi over 2. And like I said, in this one, just like sine, it bounces between 1 and -1. So it starts at 1, goes to -1, goes back to 1. Now, if we look for the reciprocal functions, they were going to look like this. So remember, we have an asymptote here. We have an asymptote here. So you should be seeing this. So let's keep them going like this way. So we don't have anything out front of the secant that causes us to reflect or anything. So nothing, and we don't have anything that's causing a phase shift. The only thing we have here is that we have this x over 4, which is the same as saying 1/4 of x. So what we have is a secant 1/4 times x. So this is a b and it's affecting period. So period of secant would be pi over 2 again. The period of secant of x over 4 is that b is that 1/4. So that would just be, 2 pi over 1/4 or 8 pi would be the period. So I think that's going to be one of our determining factors here is just going to be that pi. So let's make these a little bigger so we can see them. So this one, as you see, we should have like a little bowl like right here over that y-intercept, and we don't have that, so that's out. And this one's out. So it really just leaves these two right here. So these two, like we got that little bowl here, it's just reflected down. And this one is up. So they both have that period of 8 pi. So period is not going to be the determining factor here. What's going to be is there's a 1 in front of that secant. So it's positive, meaning it should still look like this. There's nothing to cause it to reflect. So we're looking at this graph. All right, so here we have a phase shift again. So remember, this is going to move everything in a positive direction because we're subtracting. So let me get our basic little graphs here again. So remembering what we are following is this is cosecant, so we're just like looking at what sine looks like. And we're just doing the little flip. So there's an asymptote here, here, and here. So it should be opening like this. So we have this asymptote here is at pi. And then this one's at 2 pi. Just use a couple of these to help us. So we know that this right here is going to be pi over 2. So if we want to move everything over and show the shift, we're shifting in this direction by pi over 3. Because, like I said, because of that subtraction. So that means that if I'm finding these new points, we have this one here. So because we already done some of this, with this pi over 2, if we add pi over 3 to it, that is going to be 3 pi over 6 plus 2 pi over 6, which is going to be 5 pi over 6. So we know that's where we're going to be opening up. Because this is at 0, if I add that pi over 3, we know that my asymptote is now at pi over 3. So this next asymptote at pi, so that's pi, but we're going to add pi over 3 to it. Sorry, let me go fix that. So we'd be 3 pi over 3 plus pi over 3. So that would be 4 pi over 3. So let's start taking some looks because we have a basic idea of well, at least what part this is going to look like. So there's nothing to cause a reflection. So we see instantly A is out of the picture. Now B, as we see, we're shifted over here. That asymptote is pi over 3 is here. So this one looks good. We just have to check the other ones, but it starts with the opening up. This one starts at opening up, but notice that it also has a pi over 3. So we're going to go back to those two because they have potential. This one, once again, it's opening down is how it's starting. So we're going to take this out of the picture. So these ones have the same asymptotes like we said that we were looking for. Definitely we had that shift of pi over 3 to move everything over this way. Look for is right here is the difference. Look for what's different. This one is we start at 1 and then we open up and here we start at 2. So remember default is at 1 and -1. And I don't have anything to change it here. It's still a 1 in front of that cosecant. So we would have to choose this one with the 1s. So looking for that vertical stretch again. So here we have something that is affecting that like amplitude again and the phase shift. We kind of know what we're looking for now. So let me just make these bigger. So this phase shift, this is going to move everything in a negative direction. So remember, this is secant. So secant looks like this. Move that over just a little bit. Okay, so this is at 0, 0 here. Or not 0, 0, sorry, this is at 0 here. So what we're going to see is everything's going to shift in this direction by pi over 2. So this shift over and now be starting at negative pi over 2. So we're looking for that shift. So just as a little reminder here, this is pi over 2. So if this shifts over pi over 2, that means that that asymptote is sitting here at the x-axis now. So we should see something of this shape. So we should have a bowl on this side of x and a bowl opening up and a bowl opening down. So we don't see that here. We do say that here in B. Yeah, B is okay. C is okay. D is not okay because it opens down first. So we just have to compare B and C. So B and C, as you both see that they start with this bowl is here, opening up, and then it opens down. And that we should have, like I said, one bowl on one side of the x-axis, one on the other. So it's this 4 again that's going to govern things. So remember, this is at 1 and this is at -1. So it's not going to be at 1 anymore without 4. It should be at 4 and -4. So that's all we're going to look for is to see where it is sitting. So we see here that this, get different color. This minimum here is sitting at 4, and this little maximum here is sitting at -4. So it's going to be C. All right, so for this one, we'll go do it the quick way of how we can kind of get the answer here. So once again, notice we have some are decreasing, some are increasing. So because we have this +3, that means it's going to keep the shape. There's going to be no reflection. And what we know that cotangent is supposed to do is that cotangent is supposed to decrease. Okay. So we can actually kind of ignore some of the extra stuff in here because we only have 2 of them that are going to decrease. These 2 are out of the question. So it's C and D, the decreasing. So remember, we have a little vertical shift here. So this is going to cause us to shift down 1. So we kind of just looking for this little wiggle right here. We see here that it appears to be about in this spot. Let me get some red for that. We're here, we're seeing it kind of like down here. So because we're supposed to be shifting down, we're going to pick this one as our answer. All right. Secant. So remember, secant is that reciprocal of cosine. So we're looking for one that we see a cosine curve, and that was part of it, be looking for that cosine curve. But also remember that we have this phase shift, not phase shifts, I'm sorry, but we do have a phase shift. We have a phase shift and we have a change in period. So the phase shift is going to cause a shift, and it's going to cause a shift in the negative direction. So it's going to cause a shift to the left. So normally what we would see, if we just focus on that cosine part, its cosine should look like this, but it's getting shifted in this direction. So we should be seeing it's going to be a little in this direction first and then come down. And we don't have any kind of reflection, so this is out of the question. C is a possibility. Like I said, just focusing on this little dotted curve here, that's just the cosine part. A is still in the question. B is not because B looks like it's opening, it's reflected again. So we're just focusing on these two. So this one also has a shift, a vertical shift. So this one shifts up one. So look for one that looks like it has shifted up one. So remember that what we're looking at is we're just looking at the cosine part. So this cosine does look like it has shifted up. And this cosine also looks like it shifted up, so that's kind of helped. So the last thing we need to check for, oh, I can see it now. So if you're starting to go like, okay, well, everything's shifted up. So the last thing to remember is that this point here should be at 1 and this point here should be at -1. But because we shifted up 1, this point should shift up to 2. And this one should shift up to 0. So what we have here is that this point has shifted up to 0 and 2. So we do not see that here. It is actually looks like it is not shifted, it's compressed a little bit. But this one we see everything is shifted up. So like I said, just kind of using a few things you know about the basic shape can help you very quickly pick out the correct answers here.